All right, let's talk about something every developer, every architect has to grapple with: picking the right database. And today, we're zeroing in on a big one: Amazon Neptune versus your classic relational database. It's a classic showdown, right? When do you stick with what you know, and when do you jump to a graph database? Let's get into it.
I absolutely love this analogy. It's so true. For what, decades now, relational databases have been that Swiss Army knife in our back pocket. They're super versatile, totally reliable, great for slicing and dicing data into neat little tables. But let's be real. Just because a multi-tool can do something doesn't mean it's the best tool for the job, right?
And that's the key question, isn't it? What happens when your data stops looking like a spreadsheet and starts looking more like, well, a spider web? A huge, complex web of connections. We're talking about social networks, recommendation engines, fraud detection, all that stuff. Suddenly, that trusty multi-tool feels, I don't know, kind of clunky and awkward. So this is what we're going to call the connection problem. It's that moment you realize you're really pushing that relational database to its breaking point, trying to make it handle all these super connected data points. Okay, so here's the technical bit, but it's super important. To link, say, a person to a place they visited, which is in a city, a relational database has to do this thing called a join. It's basically stitching tables together on the fly. One or two joins, no big deal. But when you need to find friends of friends of friends who also like this thing, the number of joins just explodes. And each one costs you. They're expensive. Before you know it, your query slows to an absolute crawl. So why does this happen? Well, to really get it, you have to understand that these two types of databases don't just store data differently. They literally think about data in two completely different ways. It's like two different worlds. And this really nails the difference. See, with the relational database, those relationships, they're figured out when you ask the question, using those expensive joins we talked about. But look at the graph database. The relationships, the connections, are stored as data. They're first-class citizens, just as important as the data points themselves. They're not an afterthought, they're baked right in from the start. And honestly, this is why graph models feel so intuitive. It's just how we think about the world, isn't it? You've got your main things, your nodes. That's a person, a place, a product, whatever. Then you have the relationships that connect them, like knows or bought or visited, and you can stick extra info, properties on everything. It's just so simple and natural, but incredibly powerful. Okay, so we get the theory, but how does this all translate to performance? Let's talk about the real-world speed difference, because this is where it gets interesting. You know that story, right? The one where a developer is pulling their hair out because a query is taking forever to run on this huge, messy, interconnected data set. Well, 9 times out of 10, the villain of that story is the join. That one single operation, which is the cornerstone of relational databases, becomes the #1 bottleneck. It's the thing that grinds everything to a halt when relationships get deep. This chart lays it all out. When it comes to performance on this kind of data, graph databases just blow relational away. Why? Because they're just hopping from one node to the next along pre-existing paths. No complex joins. Then you have the data model. Graph is super flexible. You can add new kinds of relationships on the fly, which is amazing for projects that evolve. And finally, the language. You use stuff like Gremlin or Cypher, which are built from the ground up to ask questions about connections. Whereas SQL, well, it can get really tangled up trying to do the same thing. And this is where we come full circle. You put down the multi-tool and you pick up the specialized instrument, the tool that was designed for this one specific complex job. And in the world of AWS, that purpose-built tool is, you guessed it, Amazon Neptune. So let's take a quick peek under the hood at Neptune. You don't have to be a cloud architect to see what's going on here. This whole system is built for two things: speed and not falling over. See those read replicas? That's how it can handle a ton of queries at once without breaking a sweat. So it's not just the database engine, it's a whole managed service that's ready for some serious enterprise-level work. And I've got to emphasize that fully managed part, because it's a huge deal. It means you're not patching servers or worrying about backups. AWS handles all that grunt work. You just focus on your data. Neptune is built to handle literally billions of relationships. It speaks the languages you need, like Gremlin and Sparkle, and it's got all the high availability stuff built right in. Okay, so we've seen the problem, the connection problem, and we've seen a powerful solution in Neptune. So now for the million-dollar question: how do you actually choose? How do you know what's right for your project?
All right, here's your checklist for when to go with a graph database. You should be reaching for something like Neptune if the connections are the data, if the relationships are the most important part, if you're asking questions that involve hopping across an unknown number of connections, like find me friends of friends who live near me, or if your data model is just messy and always changing. And of course, if you're building those classic use cases, social networks, recommendation engines, fraud detection, all of that is prime graph territory. But hey, let's not throw out that multi-tool. It's still awesome for a lot of jobs. You're going to stick with a relational database when your data is nice and structured. Think transaction ledgers, inventory systems, stuff that fits perfectly into tables. If you're doing big-time calculations, like summing up sales across entire regions, relational databases are fantastic at that. And if rock-solid data consistency, what we call ACID compliance, is your absolute #1 priority, you stick with what's proven. Oh, and a big one, if your whole team lives and breathes SQL, that's a huge point in the relational column.
So that leaves us with a pretty big question to think about, doesn't it? As our world spits out more and more interconnected data every single day, is the future of data going to look more like a network or a table? But maybe that's the wrong question. The real takeaway here isn't about one being better than the other. It's about being smart enough to know which tool to pull out of the toolbox. It all comes down to one thing: really understanding the shape of your data and the questions you need to ask of it. Get that right, and you'll always make the right choice.